talk will be both insightful and inspiring for all of us striving towards world-class research. So, Dr. Raj, over to you.
Yep. Thank you very much for the kind introduction. Can you see my laser pointer?
Yes.
Okay, cool. Hi. Hey, hi everybody. Thanks for having me today. It was very nice of Professor Murari to, invite me to have this talk slash interaction session. The title of my talk is Advances in Multilingual Machine Translation and Evaluation for Indian Languages. Just a disclaimer, I am no longer employed with NICT. I quit my job, or at least I wrapped up my work at NICT about a week ago. And where I'm going next is actually a mystery, which will be announced hopefully soon enough. From, let's say, in a little bit more time, I'll be working somewhere else. But my I still have my adjunct affiliations at IIT Madras and IIT Bombay. Before that, I was a researcher at NICT till like a week ago, so for almost 7 years. Prior to that, I finished my PhD at KIIT University in the informatics department, and before that I was in IIT Bombay as a research assistant master's student. So I have mostly spent, let's say, from 2011 all the way up to, let's say, 2021, 22 on machine translation. So almost 10 years of experience on machine translation, from rule based to statistical to neural machine translation. And then since 2020, 2021, I've been focusing more on large language models, uh, getting into multimodality, code generation, etc. So I'm trying to diversify these days. I wouldn't call myself, let's say, a master of everything. I just am a good. I have a good intuition for machine translation mainly, and recently more for LLMs. As far as the research topics go, I've been focusing on multilingual machine and speech translation, on document level translation, large scale pre-training for generation, and compact, flexible, and fast models. Most of my work has been centered around Indian languages. But the question is why, right? Why Indian languages? Why would anybody even want to take Indian languages translation seriously? Well, you have to take a look at the usage and diversity statistics of Indian languages. We know that there are four major language families, 22 scheduled languages, 125 million English speakers, but that's only 10% of our population. Of these 125 million English speakers, how many are like purely native? That is also a kind of an open-ended question. Then we have eight languages in the world's top 20 languages, 30 languages with more than 1 million speakers. And India is, of course, one of the leading economy in the world's top 5, top 10 economies. So India is here to have a major impact on the rest of the world, and there are many languages, and there are people who consume content in those languages. And why do I say that? It's because if you look at the statistics from 2011 to 2021, the number of English language speakers has tripled roughly, but the number of non-English or Indic language speakers has grown by almost 10 times or more than 10 times. And this is just 2021. Things have gotten even much more extensive in the past couple of years, past 3 to 4 years. So it's expected that the Indian language consumption of content is going to keep on increasing, and therefore it makes sense for us to focus on content analysis and natural language processing for Indian languages. And machine translation is, of course, one of the biggest use cases, because vast majority of the content is available in English. So we want to make sure that that content in English is available to the rest of the world. So we know that Indic machine translation is crucial, but the main problem is any neural machine translation model, any statistical model, any deep learning based model is data hungry. So what is challenging is that you need a lot of pre-training data, and you need a lot of downstream models. You need machine translation specific training data, because at the end of the day, the task that you want to focus on is machine translation, and you want to do machine translation models and evaluation. So there were these challenges which we've been plagued by for a long time, and one by one, me and my collaborators, we've tried to hack away at these problems and come up with solutions. The first, let's say, most impactful solution was Indic BART, and the idea is that the Indic BART is an encoder decoder language model, which essentially is pre-trained on a large amount of monolingual corpus. So now this model can be fine-tuned for any downstream application like machine translation, summarization, question answering, etc. But one innovative thing, or one specific Indic specific thing that we did, was convert all of the scripts into Devanagari. So these two scripts are for Tamil and Telugu. And if you convert all of these scripts into Devanagari, because these are all phonetic scripts, right? So you can naturally map them into Devanagari script, and you can see that where the two might be not obvious that they are somehow connected to each other. If you can read Devanagari, you can see that both of the sentences in Devanagari actually are quite similar looking to each other. So that means if you use common script representation, you have the potential to reduce the distance between the sentences, and therefore increase the possibility that the knowledge of one language can be transferred or transmitted to another language. And it also means that we no longer need to worry about large vocabularies. We can focus on smaller and compact vocabularies. So the way pre-training is done is very simple. You have, let's say, a sentence where you mask a certain part of it, and the goal is, given this masked or let's say corrupted sentence, we want to uh, recreate the original sentence. So this is called as denoising pre-training. You can mask a single word or you can mask an entire sentence. That's totally up to you. Uh, and what we figured out is that when we did downstream evaluations on machine translation on Indic BART pre-trained models, we found out that even though Indic BART as a pre-trained model is one third the size of a language agnostic pre-trained model like MBART 50, we still have comparable or better performance for English to Indic and Indic to English translation. So it means that there is value in, how should I say, there's value in investing time and effort into having Indian language specific models, because Indian language specific models will only focus on the Indic context, and it will still satisfy the requirement for working on getting the best possible performance on Indian languages. So the conclusion that we had was that it is a very important and very useful thing to focus on compact models, smaller models, which only focus on Indian languages. And by ensuring that everything is represented in a same or similar script or a reduced number of scripts, we can enhance transfer learning. We did some internal experiments. You can take a look at the paper a bit later. But we have shown effectively that this script sharing based Indian language specific model is a very strong approach to go ahead, specifically for the Indic context. Now, we have the possibility that we do some pre-training, we have some small amount of parallel data, or let's say machine translation training data, but the thing is, we want the best models, we want the state of the art models. And in order to get state of the art models, we need to do much 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 more. So for this purpose, we worked on Indictrans 2. And in Indictrans 2, our main contributions were 232 million mind parallel sentences, 800,000 human created sentences. We also had new benchmarks focusing on the Indic context. These are manually created, these are human verified, these are created from scratch, so they're very high quality and they cover about 13 to 14 domains. And then using the mine data, created data, etc., we created the Indictrans 2 model, which back in 2023 was the state of the art open source models for Indian languages. And so far it is still one of the best models, open source models for Indian languages. It's also supporting all 22 languages in the 8th schedule of the constitution. So this was a pretty big thing that we had done in AF Abharan. So, as I mentioned, there are a variety of domains. So, you go have education, economy, culture, tourism, etc. And we have it in two styles. One is in general written style, and one is in conversational style, like a dialogue style. So, we want to evaluate Indictrans to not only for general translation, but also in a kind of conversational style. And our result showed that our model actually does pretty well in both domains, which also means that the data that we'd collected also has general style as well as conversational style. Now, the way we train Indic Trans 2 was, by multi-stage training. So we have, first of all, we have a stage of training on large amount of mind corpus, which is like 200 million sentences. We then fine-tuned it on the high-quality human-created data. Then once we have a high-quality intermediate machine translation system, we take 400 million monolingual sentences and we back-translate them into Indian languages as well as in English, depending on what the source language is. And then we just repeat this entire stage but with this additional amount of data and the fine tuning on the seed corpora that gives us the best possible machine translation system. And this stage wise approach is what led to the best possible improvement. In fact, we increased our performance by anywhere between 1 to 4 CHRF points by this robust training approach. So this is a very useful thing to do. And when we compared Indictrans 2, if you look at the red bar and then compare against existing models like Azure, Google, which are closed source, and NLLB 54 billion mixture of experts, which is open source, we can see that our Indictrans 2 model is comparable, if not better, in a number of cases. Despite Indictrans 2 being only a 1 billion parameter model, it can outperform a 54 billion parameter model very easily. So it's not the size of the matter, but it's the amount of investment and the amount of time you and the quality of data that you utilized to train machine translation system is what helps. So you have to be very careful about choosing data, cleaning data, and making language family specific decisions to get the best possible systems. So now we know that monolingual data is helpful, but the question is, where do we get monolingual data? How do we get monolingual data? And that, I think, is the root of a lot of Indian language LLM training, which is currently the hot buzz these days, right? So when you don't have data, there are two ways. You can mine it from the web, which is very good because it's free of model biases, but it takes time and it's exhausting, and you need to clean it also. On the other hand, you can synthesize it, which is not an ideal solution because it contains model biases. So if a model is biased towards a certain gender, or if it is biased towards a certain style, then the translated content will be in that style. So it's not possible to produce any diversity in the data that you generate. But the advantage is that you can produce this at scale. So essentially, you can just take fine web, you can just take any large English corpus and translate it into all 22 Indian languages, and you'll probably have a massive amount of monolingual data. So this is where we came with Indic LLM suite, where we took an intermediate approach. We took a combination of both, and we produced what is known as Sangraha. So now this thing over here that represents the pipeline for creating Sangraha, we have sources coming from PDFs, which we OCR'd. We have existing corpora. We have Wikimedia. We have web corpora, which have been verified, like URLs which have been verified and scraped. We have videos from YouTube, which have been subjected to automatic speech recognition by some Indic ASR models which were developed in AFA Bharat. And all of this goes into what is called as the Setu pipeline, which is essentially a scalable Spark-based pipeline to deduplicate, to clean, and to ensure that the generated final corpus is of high quality. And we end up with roughly around 250 billion tokens worth of data. For more concreteness, 250 billion tokens is roughly the size of the corpus that you would need to train a 7 billion model without underutilizing its capacity. So this is just the bare minimum that we have managed to create, but it took several months, and a vast majority of this data is synthetic, which was obtained using machine translation. So you can see that machine translation is actually fast, and we came up with this 163 billion tokens in only a couple of weeks, but the scraping, verification, processing, that is the thing that took most of the time. So you have to be very careful about the overall process. So this entire effort took about a year, almost a year and a half, if you consider the very beginning of it. And we have leveraged Indic Trans 2 for this purpose also. We also have this instruct data, which is a translation of variety of data sets, as well as data sets created from scratch using LLMs which converse with each other. If you are interested, please take a look at the paper on how we came up with this data. But this contains instruction data as well as toxicity data, where essentially you have examples of toxic queries and toxic content, which you can train the LLM not to answer. This is very necessary, and everything has been machine translated at the end, because getting this kind of data in Indian languages directly means getting annotators, and it's not so straightforward. But the translated data has been verified, and we found that it is of good quality. So if we have synthetic data, right? So I mentioned that we have 163 billion tokens of synthetic data. That is pretty much 2/3 of the data. But how good is it? Is it reliable to use synthetic data? So this is where we did a little bit of focused experiment on tiny language models and translation ease. This was with my student Meet Doshi at IIT Bombay. I think he's in IBM right now. And the idea is very simple. We have clean monolingual documents in, let's say, English, and we want monolingual data in Indian languages. So first what we'll do is sentence level translate each of the sentences in the document, and we get what is called as the unfiltered translationese or synthetic documents in the target language, which is an Indian language. Now assume that we have a small amount of clean monolingual documents for the target language, which is always realistic, right? It is possible that we can have about 1 million tokens, or like say 10 million tokens worth of monolingual data. We can train a tiny language model. Now, this is not billions of parameters. This is not even hundreds of millions of parameters. This is like 28 million parameters, very tiny models. These models by themselves are not very good at any downstream tasks, but they can be used to at least detect which of the unfiltered documents obtained using machine translation can be removed or can be retained. We can get perplexity indicators as the quality of the documents, and then we can have filtered content, and then this can be used to train language models at small or larger scales. And essentially what we found out, if you look at this table, there are too many numbers, so I'll break it down. We have natural language understanding, and we have natural language generation tasks. Now HI clean represents a language model which was trained only on Hindi. and that to the clean part, which is web script data. And this essentially represents the baseline of what you would get when you had the cleanest possible web data and not synthetic data. Now, if we took unfiltered synthetic data, which means we translated content from English to Hindi, but we didn't subject it to any filtering, then we end up with some reduced performance. As you can see, the average performance for NLU goes from 77 to 74. For NLG, it goes down a little bit, not as much, but it means that the model is sensitive to certain tasks or certain types of tasks. Now, if we filtered the content and still maintained the amount of tokens, you can see that the average performance goes from 74.26 to 76.63. That means we are able to reach the quality of high quality web scrape corpora. And now, if we add a certain amount of original clean web scrape corpora, only 10% of the synthetic data, then we end up getting performance which is comparable to the original data, which has purely been web scraped. In other words, if you have synthetic data, you need to clean it and you need to make sure that you have a certain amount of clean, high quality web script data, which you put at the tail end of training. And essentially, you end up getting a very good quality of model. And this works on Hindi, this works on Gujarati, it works for basically any of the tasks that we've experimented. And then the question is, we've been trying to make machine translation dedicated models. We're trying to use synthetic data, but these days everybody wants to work on LLMs. And although I don't believe that the LLMs are like an end solution to everything, we still need to ask the question how good these LLMs are for Indic machine translation. So we did some work on prompting for machine translation, where you know that if you do what is called as few shot prompting, you need to give an LLM an example of what machine translation looks like. So, for example, if I want to translate from Hindi to English, I give it an example, a parallel example, and then I give it the actual testing Hindi sentence which I wanted to translate. And the LLM essentially translates this Hindi sentence because it has been given an example. So, this is called as in context learning. But now the question is, how do you decide what kind of example pair or let's say demonstration to show to the LLM? And this is one interesting question because we might have an existing data store of a large number of machine translations, parallel sentences, but we want to choose the best possible one. And what people have done is they've used either, let's say, some kind of basic similarity metrics, or they've used some very shallow approaches. But we wanted some, let's say, instance or demonstration scoring mechanism which considered variety of features. So we did a bit of investigation on a large number of features which involved similarity, embedding similarity metrics, character F, comet scores, labse, uh, on the number of tokens, on perplexity, and a variety of such metrics. And this allowed us to rank, let's say, these demonstrations and choose the best possible demonstrations. And as a result, we came up with what is called as the CTQ scorer approach. Essentially, it is a neural ranker which ranks, or let's say retrieves, the best possible demonstration for the current sentence to be translated. And we did some evaluation. I'm not going to go into the details because I'm kind of blazing through all the things that we've done. But the long story short is, if you randomly select demonstrations, then the average performance across different translation directions tends to be around 51.03. But if you choose features correctly and you rank according to this neural ranker called a CTQ scorer, then you end up getting a performance increase of almost 2.5 points average across different languages. For some languages, the jump, like Hindi, the translation quality jumps from 44 all the way up to 50. So it means it is valuable to invest into retrieval approaches specific to machine translation that focus on the nature of sentences, on the similarity between the current sentence to be translated and the sentences in the data store. So retrieval for machine translation is very interesting, and general purpose retrieval is also pretty good. And then the question we have is, can we use encoder decoder probabilistic language models for machine translation? And the idea is yes. The long story is that normally what we do is we use decoder only models, right? In decoder only models, we just do in context learning. We give, let's say, the demonstration, we give the input sentence to be translated, and we ask for the output. But when it comes to encoder decoder models, this is not exactly feasible. However, as a proof of concept, the people, Patel et al., they showed that you can actually do in context learning for encoder decoder models, but where you generate one token at a time. Once you generate a token, you just append it to the prompt and you keep on repeating this till you reach the end of the translation. However, this approach of generating one token or a phrase at a time is not particularly efficient, and it doesn't focus on language specific properties. So one specific property that we leveraged is monotonicity. So we know that when we translate from Indian languages to Indian languages, you know that there is a word order is the same usually, and there is almost a one-to-one relation between words and phrases. Unlike between English and Indian languages, there is a word order change. Sometimes there is word dropping. Sometimes there is word insertion because of the big gap between the two languages, but Indian languages are very similar. So we exploited what this monotonicity is, and we came up with this prompting approach, which is called as deco empty or as decomposed machine translation. And the simple idea is that we do translation in two phases, and we translate each chunk. Let's say we first divide a sentence into individual chunks. We translate each individual chunk separately, independent of the other chunks. Now, once we have independently translated chunks, we use these independently translated chunks to generate a revision of each translated chunk and improve the translation quality. So it is independent translation and then contextual translation. And at the end of the day, so this is the approach. Again, since I'm blazing through, I will not go through details, but long story short, essentially, we utilize the monotonicity between two Indian languages to only translate the chunk which makes sense for that particular language. And when we do this, right, what we end up with is a monotonic sentence translation mechanism using an encoder decoder model. And we found out that the translation quality between, let's say, generating one word at a time is much better than when you do this contextual translation but with chunks and with monotonic alignment. And you can see that the translation quality just jumps by a huge amount. This means that you might want to invest into linguistically related languages translation, where you can leverage certain properties of relatedness, monotonicity, script similarity, word similarity, etc., and then you'd be able to come up with better translation systems or translation approaches. But this is assuming that a particular LLM supports Indian languages. So when we did our experiments, we did experiments with MT5, and MT5 supports Indian languages. But what if we took Llama 2, right? This is, let's say, 2 years ago. In Llama 2, it didn't support Indic languages very well. It barely had any vocabulary for Indian languages. So what do you do with this situation? Well, the nice thing is that Llama can understand this sentence, which is written in Devanagari, but it can understand the romanized version of that sentence also. And this we found out just by casually prompting Llama with, say, let's say, this romanized version of Hindi, and it ended up completing that sentence in that romanized format. So that means Llama has been inadvertently exposed to a bunch of romanized Indic context. So we thought, why don't we push this further? So we came up with Roman Setu. This was one of the papers that got an award, by the way, and where we used romanization as a bridge. And the question is, why romanization? Because romanization means you can reduce the overall fertility of a model. So fertility means the average number of subwords a particular word has been broken down into. So if you look at Gujarati, if you take a word in Gujarati and if you feed it to the Llama 2 tokenizer, it ends up being broken into 18.44 subwords on an average. But if you romanize that particular word and then tokenize it, you end up breaking that word down into 3.39 subwords, which is very nice because now we can handle almost 4 to 5 times fewer number of tokens to generate a Gujarati sentence, which is very good from an efficiency perspective. And this has an impact on basically every single Indian language, where if you use the original script, you have a large fertility, but if you use the romanized script, it has a low fertility. Plus, the Llama 2 model could understand this. So that means we have the chance to utilize romanized representations. The model kind of understands it. And then we also have the opportunity to transfer knowledge from English to this Indian language. So the way we did it is, first we took native script data and we romanized it. And the way romanization was done was using the Indic transliteration model, which is a neural model. Then what we did is we combined it with English data and we did continual pre-training of Llama 2, and we got what is called as a romanized version of, let's say, Llama 2. Now we have some English supervised fine-tuning or downstream task data, which we of course translate and romanize to the target Indian languages, and we do instruction tuning of this continually pre-trained model, which and we end up with a fine-tuned model. This fine-tuned model is not designed to handle to handle the native scripts like Devanagari or the script for Malayalam, Tamil, or Telugu, but is only designed to handle romanized versions of these scripts. And we are hoping that this fine-tuned model is going to do better than any model that we can fine-tune using only the native scripts. And if you look at the overall results, we found out that just look at this particular column over here. If we use the native script representation for Indian language to English translation, you get a CHRF score of 49.78. But if you use the Romanized representation, we get a slight improvement for Indian language to English. That means what this shows is that Llama is good at understanding Indian languages, but how good is it for generating? So when we looked at English to Indian language translation, when you use the Romanized script, the CHRF score we got is 37.40, which is not that great, but okay. But the when you use Romanization, the CHRF score jumps from 37 to 46, which is almost a 10, almost 9 to 10 point improvement in CHRF. This is a big jump. This means that when you're generating in Indian languages using a model which doesn't support Indic script that well, using Roman script can really, really increase the quality of performance. And this works for the summarization task and also for the headline generation task. And this is very necessary. This is a very important result because it shows that you can essentially leverage certain unintended consequences or unintended design options to harness those options and then improve performance for the specific language or specific task that you can work on. Now I've talked about a lot of modeling. I've talked about machine translation. I've talked about Romanization. But what about evaluation, right? We need to know whatever evaluation that we are doing, whether it's reliable or not. And one of the things that we need to do is we need to consider which metric is reliable. So there have been multiple metrics that have been studied for English translation from English or to English. We have Blue, we have Meteor, TER, embedding, averaging, Bird score, Prism, Blueart. Among all of these, we need to know which is the best. So what we need to do is what is called as meta evaluation. And meta evaluation means that once we have these scores, we need to see how correlated they are with a human score. So humans would be given let's say translations, and they'd be asked to rate these translations. Now if the human rating is similar to any of these metrics, then that correlation is said to be high, and therefore the metric with the highest correlation with humans is the most reliable metric. So if you design your own metric, you should meta evaluate it against some human annotations. And this, of course, has pros and cons, and we'll be able to figure out which is a very reliable metric. So the way we, let's say, uh, get human, let's say, ratings is we give, let's say, a source sentence, we have a translation, and we ask annotators to annotate up to 5 different errors which are present in the sentence, and we want them to tell us how severe that error is. There are a total of 13 different categories of errors and 5 severity levels, and this is a very intensive, a human intensive task, but at least it allows us to get some kind of data where we can judge whether a metric which is being used is close to being human quality or not. And also, once humans have annotated certain data, we can simply fine tune a model to have our own, let's say, neural metric which can mimic the rating quality or the rating behavior of humans. Okay, so we did a bunch of, let's say, error annotation with the data set that we created for 5 Indian languages, and then we extended it for another 4 Indian languages. And we found out that among the, let's say, automatic metrics, which is Blue, Sacrebrew, CHRF, etc., CHRF plus plus is the highest rated metric for Indian languages evaluation. So English to Indian languages evaluation. It is the highest, the metric that gives the highest correlation. Now, there are embedding based approaches which come in 2 different categories. One is these kind of language agnostic bilingual embedding approaches, and let's say non-bilingual approaches, or let's say pre-trained model based approaches. And you can see that these have some good correlation. They're not as good as CHRF all the time. But then finally, you come to these neural models which have been dedicated, fine-tuned on human annotations, and you can see that these give the highest possible correlations with human annotations. So at the end of the day, if you get a huge number of human annotations and then you fine tune the model to predict these human annotations, you end up getting the best possible, let's say, evaluation metrics. There are pros and cons. This can be gamed, but at least it's the best approach that we have to get the best possible evaluation metrics. Sorry. So essentially, we can train our own neural models on human annotations that we collect. And at the end of the day, we also train what is called as the Indic comet model, where we fine tune comet variants on the MQM, or let's say error annotations that we have obtained using human beings. And we find out that, okay, it is definitely better to have, let's say, a Indian language specific Comet model fine tuned on human annotations for Indian languages, and it's better than any of the correlation, or let's say it better than any of the MT evaluation metrics which are publicly available. So this model I think is publicly available, but it might be a bit outdated. There might be better ones which would be arriving soon. So, in summary, I've talked about Indic BART and low resource machine translation, where I showcase that language family specific models are crucial. I've talked about Indic Trans 2, about how we created 22 scheduled languages with language family focused efforts. I've talked about Indic machine translation using LLMs. I talked about neural rerankers, leveraging monotonicity, leveraging transliteration. And then finally, I talked about Indic machine translation evaluation, where I described briefly on how you can choose your metrics wisely and how you can make an Indian language machine translation evaluation metric, which is optimized for Indian languages. And future work, I mean, there's a bunch of future work, right? You can have speech translations. Actually, we did this for Bhasha Anuvad, which is publicly available. We want to work on dialects. We want to do better evaluation metrics for synthetic data creation. We want to do neural re-rankers, which are better, although in the current situation, maybe this is not such a great idea, but it might be worth it from a theoretical perspective. Larger models, Indic BART, I've been meaning to train in Indic BART V2 for quite some time, but I just haven't found the time for this because there are other more priority tasks. And then, of course, scaling up monolingual data to identify how to obtain good synthetic data and how to overcome, let's say, translation ease effects. That's pretty much the end of this very quick blitz talk. I introduced many concepts. I hope kind of like gives you an idea of the things that I've been able to accomplish thanks to my collaborators at IIT Madras and IIT Bombay. And yeah, now we can do question answering. Professor Murari, please.
Yeah. Yes, yes, sure. Thank you. Thank you very much for this wonderful presentation. We actually got to know the summary of the wide range of research that you have been doing, particularly Indic language, with focus, lots of focus on Indic language. I think that has helped many companies as well. I've seen many companies using Indic LLM suite and many others which are already available on GitHub as as part of their code base to support their whatever product they are making, which requires multilinguistic support in India particularly. So it has been really impactful work that you and your collaborators have done. I'm sure you have plans to do many more impactful works as well. Yeah. So I was having one question, like so this entire, like, lots of focus is on machine translation and low resource languages, and like how do we do translations in effective manner and better quality. So now with LLMs now, usually most of the LLMs have been pre-trained on whatever data they could get their hands on over the internet, including it, they may have some Indian language data as well, like whatever is out there, right? So but now we are observing a lot of value in small language models that are pre-trained also for a particular task, and which could be used, which could be much more reliable, although LLMs are also pretty reliable for the some of the tasks. So is there any kind of value in training a model, let's say pre-training a model from the scratch for a particular language, right? So I know we are doing the translation, so we are, the translation itself is becoming better and better. So it may seem there is no need to pre-train a model just for Hindi, or let's say just for Tamil or Telugu, whatever. So but do you see any value in it for long term, like as we start using these models more and more in almost every applications that we may use, right? So yeah.
So that's a very nuanced question because I would say that the answer is that really depends on your task. If your task only involves purely machine translation, then you don't need to train an LLM or a SLM or anything like that. All you can do is just take, let's say, a large amount of parallel data which is publicly available, enhance that with back translation if you need, with some monolingual sentences, and you can just build a very compact model. So one of the things we did is we had Indic Trans 2, which was a 1 billion parameter model, but then we also compressed it to a 200 million parameter version, which is almost 2 to 3 times faster, and its performance is almost the same. And some of the creators of this model also extended this model to have longer context, which can support almost 1,000 tokens. It can translate entire documents. I would say then that Of course, you can train your small language model. Of course, you can take maybe a larger model, you can compress it, you can distill it. Training from scratch means that you have the methodology perfectly understood to train your small model. And you really need to see what your compute availability is. You need to see what are the different aspects, or let's say what are the different situations where this particular what task we are trying to solve. And then and only then it would be a good idea. I would say yes and no both. Yes, if your task is better solved with some kind of language model trained from scratch. No, if you already have something available and you just need to tune it to make it better. So it really depends, it really depends.
The reason like why I was having this question, like because I have been like reading up and like seeing some scenarios where LLMs have certain ideologies and certain values, preconceived notions which is ingrained in them because they were highly trained on like Western content, right? So if we want, again, it meant, I'm not asking just as a researcher but as a, let's say, in general, like uh, so if we want to address those kind of scenarios, even like we had this chat gpts recently 4.0, right? So there was this, it has some sycophancy, right? So it was more I don't know, agree, too much agreeing with the whatever the user was talking about and all those things, right? So those are like quite nuanced kind of issues, which even the company themselves might not be aware of, like how did they occur. So but because the entire thing is from English point of view, so does language play a role in kind of uh, like for these issues and solving these issues, like both way?
Right. So, see, I mean, I think we all know that the LLM is what data is being fed to it. So, if you're going to feed it Western-centric data, it is just going to have Western-centric values. If your Western-centric data is a lot larger than your Indic-centric data, then it's going to be biased towards generating more Indic-centric data. So, there are, I mean, there is no way to give a model absolute certainty that okay, this model is definitely going to generate content. So personalization is a very important thing, and I think these days there are more and more LLM works which focus on personalization. Personalization is actually is not a new idea, right? It has been around for more than a decade, more than 2 decades. But now with LLMs it is possible for you to have personas for each individual user and then satisfy that user's constraint. So this will be based on the interaction that a user has with an LLM. Now, if initially it might be the case that the LLM generates some kind of Western centric content, but then if the user gives feedback, no, 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 this is not what I want to see, I want to see this, then it is possible to, let's say, modify the system prompt. It is possible to modify, let's say, some kind of initial in context examples that may be happening, and focus more on generating these kind of, let's say, value centric mechanisms. So this is all of this is at the root of a bunch of works on let's say culture aware, let's say LLMs, right? And we found out that a number of times LLMs are only aware of a handful of cultures, whereas most cultures it is not able to handle. Or if you ask the LLM questions about a specific culture in English, it might know something, but when you ask about that culture in that culture's language, it will just not be able to answer. So it's all about the kind of data that the LLM has been trained with, in what way it has been fine tuned. Some people have said recently that reinforcement learning simply amplifies the biases which have been present in the pre-training data. So if that is the case, we really have to know what kind of data that we are working with, and then if we want our LLM to be let's say aligned to a specific way, then you need to include that kind of data during the pre-training stage or during the fine tuning stage. And then after that, do a post analysis based on whether these biases exist, and then do a debiasing step. And there has been a lot of work on gender biasing, culture biasing, and debiasing approaches. So it would be nice to invest in that.
So basically you are saying that which language we use to pretend, it doesn't matter, the data quality we can like.
Everything is the data. So for example, if you uh, take Odia data, but it is only about about hip hop music in America,
Okay.
and it has only a small amount of information about, let's say, the festivals in Orissa, then it is just going to end up talking mostly about hip hop, no matter how many times you ask it about festivals in Odisha, it will probably rarely speak, talk about that information. But it really depends on how well you have refined this model or fine tuned this model or aligned this model. Otherwise it will just keep on just go off on its own tangent. Language, I'm not sure if language is an is one of the confounding factors, because it's possible that, okay, there might be certain languages where if you train the model, even if you have a skew in the data, it might be able to produce de-skew it by itself. Some languages might encode for information in a different way based on the scripts, based on the grammar. We've seen that, okay, if you take the same exact data, translate it into Hindi, and then you train a model on English, you train the model on Hindi, it's exactly the same data, the
Oh,
accuracies can be very different. So why is it that one model has a good accuracy in English but a bad accuracy in Hindi, even if you have the same identical data
yeah,
trained from scratch?
yeah.
So that is not, this is unknown, we don't even know why this happens.
Because we are seeing some examples where like these DeepSeek, I think Quen models, they switched in Chinese, right? In their like reasoning tokens
Right.
while trying to answer some question, right? So
Right.
that is interesting to see. Like,
Right. So I think the reasoning is the reason for this switch in reasoning is because when the reasoning level fine tuning is taking place with reinforcement learning, if your reasoning data itself, if there is no penalty on switching languages, it will just generate anything. Because I don't know who is the researcher, but there was a nice blog article. I forgot. I think one of the people in Mila or something. They showed that what you think of reasoning is not necessarily reasoning. Sometimes these models will even reason with wrong facts. Just that it has been optimized to generate some intermediate rambling to get to a better result.
mhm,
So it is very possible for us to, so you can think of it this way, right? You can take, let's say, a supervised fine tune model. You can say, okay, I want you to generate some reasoning patterns and generate 4 to 5 different reasoning patterns to get to the same exact output. Now I can also say, in the middle, generate 100 tokens worth of rubbish and reach to the final answer.
mhm,
Now if I fine tune the model to optimize for this rubbish that is generated and I still can get the answer, that means reasoning has no value at all. Now the question is where reasoning should be useful, where reasoning should not be useful, and how you optimize your model. It is possible that the model in that rambling might encode for information that we don't understand but the model understands.
mhm. Yep, that's really interesting to know how these models are kind of coming up with answers, right? I think there's a lot of scope to work in this direction, uh, right?
Right. So reasoning is very good in the sense that reasoning is just a glorified version of chain of thought. Chain of thought is from 2021, so reasoning is not new. It's
Mm.
already there since 2020, 2021. It's just that now people have formalized it into what is called as arbitrarily long reasoning chains. And when people did chain of thought, it was very short reasoning chains, because it was like, okay, Ram has 4 apples and Bhim has 5 apples. How many apples do they have in total? Okay, so they say like, okay, x equals to 5, y equals to 4, so x plus y equals to 9, and that's the total number of apples. But now people have come up with more long, complex reasoning chains, and that is what people are more interested in. It's like, what are these reasoning chains, and why does reasoning lead to better results? In some cases, of course, we can understand that when it's there is reasoning, it's possible that the LLM was fed some mathematical textbook, right? And in the mathematical textbook, whenever problems are solved, word problems are solved, you usually have the explanation like, okay, let us assume that you have x equals to 4 for 4 apples and y equals to 5 for 5 apples. When this reasoning is done, the model's probability distribution is adjusted to match that text which it was trained on a very long time ago. At some point of time in the model's training, that distribution has been stored, has been encoded. So when this reasoning matches that particular distribution, it is just regurgitating certain reasoning patterns that were used to get to that word problem's answer. And maybe there's a maths book on 10th standard geometry, which there was an example, similar example. So as long as the reasoning chain simulates that particular behavior, or let's say word problem solving behavior which was described in the textbook, the odds of you getting to the correct answer are much higher. Because when you think about it, nobody says, okay, no, if somebody gives you a word problem, you're not just going to give the answer. In your mind, you're always going to think like, oh, okay, even on pen and paper, when you try to solve, even when you look at the maths textbook, the answer is not given directly. There is always some explanation. So wherever there are explanations, it is very likely that the model will retrieve that kind of behavior on how to get to the answer and likely get a better answer. But it is not necessary that reasoning is good for everything. There are some cases where reasoning is completely not necessary.
So does it help in translation?
Good question. We have not found any evidence so far.
Okay.
If you look at the decomposition machine translation, the deco-empty approach, it is a kind of chain of thought based approach, because we have divided the entire translation part into translating individual chunks and then combining chunks one after another. If you look at it, that is somehow a chain of thought where we have given incomplete translations and asked to complete every individual translation one after another. So it is a kind of chain of thought, not exactly, but a kind of chain of thought. Like we say, like, oh, okay, you have translated this much. Now, given this context, try to translate the next part. Keep on prompting it one step at a time. We have found that it has some advantages, but there has been no concrete evidence or satisfying evidence where you say, like, okay, now I want you to translate from language A to language B, but I want you to go step by step. That has not been explored, and I think that's overkill, because machine translation already has a lot of data. This might be more useful for languages where there has is not much of data. We have only like a handful of examples, in
Hmm.
which case breaking things down, reasoning things would make a lot more sense.
Yeah, yeah, yep, makes sense. Okay, so it's a more kind of related to our lab, I guess. So how do you evaluate whether an idea is paper worthy? Can you share an example from your own experience? Like, initially the idea might have seemed trivial, but turned out to be really impactful.
So the Roman Setu work is a classic example of what we considered as a very low-hanging fruit, but ended up being pretty valuable. So I don't think of ideas as I want to publish this versus I don't want to publish this.
Mhm.
Ideally, I want to publish everything that comes out of my work. What we do is a lot of trial and error, a lot of fail fast kind of solutions. So it's typically that since I'm one of the senior researchers, I'll come up with a bunch of ideas during a meeting. I'll say, okay, try this, and see which is the most promising one. And usually these would be based on existing papers, based on some very easy to implement ideas. And when it comes to these kind of basic ideas, right, you can try these things in a week. You can have 4 to 5 different basic results, proof of concept. You don't need to go too deep into it.
Mhm.
Once we find out that, okay, out of 5 ideas, one of them will work, usually it's only going to be one which works, or even all 5 will not work, in which case the cycle continues. But if we see, okay, something is promising, then we try to get to a minimal proof of concept, which where we try to see, okay, is this minimal proof of concept something that has brought some new observation, some novelty, some new insight which was not there before. So when it came to romanization, not no one in the world of LLMs had ever tried to enhance an LLM with romanized content or work with romanized content. So we are
Mhm.
like, okay, is this even worthwhile? Because Llama has definitely not seen much. Llama 2 had not seen a lot of Indian language content. And if it had not seen a lot of Indian language content, then would it even work in a romanized format? I mean, there is no need to believe that, right? So we wanted to see how good the quality could be. If the quality of translation is just bad, if the quality of outputs is just bad, there is you cannot sell this. So that's why we kind of worked in small increments. The moment we realized, okay, we actually have a number of indicators that this idea is good, that is when we decide to formalize it, write an archive paper. And then once we have an archive paper, once we've kind of flag planted, we just go be very extensive, be very thorough. Of course, this requires a lot of compute, as you know.
Yeah.
But we somehow managed to, let's assume that we figured that out. Then it's just a matter of filling in the gaps, and that is just half the work done. Once you submit it to peer review, if you've done peer review, you know that it's mostly bad. These
Yeah.
days reviews are bad quality. Sometimes the meta reviewers are amateurs.
Yeah.
The senior area chair will have their own opinion. Program chairs might be mistaken. So getting a paper accepted or published is, I would say very random these days. Even if your work is good, it cannot get published for 1 or 2 years. If your
Mhm.
work is absolute garbage, it can still get published in one instance. I have a couple of papers that I've written with some students, which I thought this is unpublishable work, but
Mhm.
because of some miracle, it got published in ACL. So I would say that there is no idea which is too good or too bad. Peer review is a very bad way of judging whether someone's research is good or not. It is whether people use your work or not is the indicator of true quality. So put your work on archive. If it's worthwhile, advertise it. Of course, you should advertise your work. But if it is useful, people will use it.
Yeah, that is really, really great kind of way to explain the current research landscape. Because as
Yeah.
a student, because they do have papers in mind. Because as like for example, I myself may not be looking to do something for a paper, but still I have to guide them so that their idea does eventually help them. At least get a paper submitted, accepted, whatever, right? So yeah, so this is nice way to look at it. Yeah, thank you.
Yeah, I can say that to for a student who is looking to publish, uh, this publication, right, research publication, if you want to publish a paper, you should not rely on your professor all the time to give you feedback or like, hey, what are you doing? Give me your update for your week. Proactivity is the only thing that helps you. If you are really passionate about publishing, then you have to come up with results every week. If you don't have results, you have to read papers, you have to do something, and then you should at least send like a one liner or at least one paragraph saying, okay, this week I tried this worked, this didn't work. If you're not proactive, then don't bother with this publication game, because the publication game is very draining. It's emotionally draining, it's sometimes physically draining. And your professor will have their own things to do. They will not necessarily be able to sit and think of ideas. Here is what I usually tell my students: you should not require me to publish. My existence is more like, in case there is an emergency, I'll help you out. I'm here to provide the environment. I'm not here to hold your hand and do research. You should be doing research by yourself. If you're strongly motivated, you will publish by yourself. If you're not strongly motivated, you shouldn't waste your time publishing, because publishing is not for the weak hearted. That's all. It's very, I know it's very very harsh to say this, but it's not for the weak hearted, especially in this era. I don't recommend publishing if you are like, oh, can I publish, can I not publish? If you want to publish, just publish, that's it.
Yeah, I think lots of the points are similar to what I tell to my students. So I think my students should be able to relate to that. Yeah. So actually, I tell some of the students, like if you are looking for a job, maybe don't spend too much time in publishing paper and all those things. You can just practice your coding and whatever.
Yeah.
Like that will be much better, because publishing is more if you have genuine interest in doing some research, or like you want to do masters or PhDs. So usually that career is kind of the where you'll get the maximum advantage or like benefits of publishing a paper. If your goal is to go for jobs immediately, then may not should not spend too much effort and time here. Maybe do what they're expecting, like those companies
Right.
expect for you to
Right.
prepare. Yeah.
Yeah. So I have one thing to say over here. Many students, many people ask me, should I do a PhD? And my answer is usually this: if you're asking me whether you should do a PhD or not, you shouldn't do a PhD. You should do a PhD only if you really want to do a PhD. A PhD is not like, okay, I'll do a PhD, then I'll become a senior scientist somewhere. That is not the goal of a PhD. A PhD is purely for the love of research. You love research, you do PhD. You you're kind of on the fence, then you probably figure it out before asking the question, should I do a PhD or not? You shouldn't ask that question. Just do it if you want to. If you are planning to get into industry, and industry has requirements for maybe a couple of papers, work on something open source, right? Work on some kind of idea, some toolkit, some kind of model, some fine tune. You can use collab is possible. You can use unsloth and then collab, and you can come up with any kind of model that you want. Showcase it. That is good enough for you to get into industry. But for PhD, you really need to think that I'm not doing this for money, I'm not doing this for some grand purpose. I'm doing this because I really like to sit behind a computer, hack away at a problem till I get to its core and then solve it. That is what the main essence of research is.
Okay. Thank you again. So another kind of, I think this is more recent phenomena, I would say, kind of LLM phenomena in research, which I have observed. I also tell to my students also that do you stick to one particular theme of problem to work on, or do you diversify your problem statements to target? Because nowadays it seems the problems itself are becoming newer and new problems themselves are coming, which previously we were not even thinking about solving, right? Because LLMs are becoming are giving us so much power, we could think of solving problems which previously we will not even imagine. Okay, maybe we could solve this through AI. So what, because I'm personally looking, actually this is my, what I'm doing right now is I'm diversifying to different topics because there's so many topics to explore. And one topic, if some particular like which are like more known problems are getting solved by these big labs very quickly, so if you're aiming that, it becomes kind of obsolete. So what is your take on this scenario?
Um, so, um, right. So, give me a moment to think. Right, let me think. What would be a
Yeah, sure.
uh, here's the thing, right? The problems are becoming uh, relevant and then not relevant very quickly. Uh, my take is, if you're a PhD student, you should have one main project and one side project. If you're a postdoctoral researcher, you should have a few side projects, multiple of them, because as a senior researcher, you're kind of trying to diversify. As a junior, as a bachelor student, you should have 2 to 3 side projects. Main project is usually not feasible. Your main project should be like helping a master's or a PhD student. As a master's student, you should again have one main, one masters. So PhD is like the peak where you should only have a limited focus, but other ends is usually you can kind of diversify and look at multiple problems. Now the problem is that the field is moving so fast that it's very hard for you to, like, if you stick to only one thing, you might end up being scooped up very easily. Someone is going to come up because you think of
Yeah.
an idea, next morning there's a paper on archive. That's how it
Yes,
happens.
exactly.
So you cannot be complacent and say like, okay, no one is working on graphical models for machine translation, so I'm the only one who's going to work on it. Sometimes it's true, but not always. So always have a backup. But if you have too many backups, you're just going to end up not doing well on anything.
Yeah.
So look at your capacity. Based on your capacity, choose maybe 1 or 2 side projects, and maybe like in a week work 3 days on your main project, and 1 day each on, like, let's say, side project. And it's enough to make progress. But the important thing is you have to do daily consistent progress. You cannot be like, okay, I am going to take 3 weeks of vacation and then suddenly in one burst I'm going to come up with a spectacular mind-blowing ideas. This is only possible for a few people, but it's not possible for everyone. Most of us are human beings. We are not geniuses, so we need to actually put in daily consistent effort to get to a result. So if you think like, you know what, like, it's not like passing an examination where you study one night behind before, it doesn't work. Research is not like that. Research is, sometimes it's like that. It's like 1% of times where you have this mind-blowing idea. Like, for example, a couple of months, no, 3 months ago, I had this random idea with my colleagues, and I was like, hey, why don't we do this? It was one line change in code. We did some quick experiments and we published a paper in MT Summit. That happens once every 6 years for me. It doesn't happen to me all the time. So you really need to be consistent and very proactive in these situations.
Yep. Again, like really, I think these are like really good points that we do know, but sometimes students miss it actually in the process. Basically, they start with good intentions, but I think they need, repeated reminders, like, okay, where the focus should be, right?
Right. So as a student, so I can say one thing. I think the students of this era uh, highly underestimate the value of a young faculty and how invested a young faculty can be in their own student success. So I'm not going to take names, and I don't mean this in a negative way, but back 10 years ago, I didn't get the guidance I am giving to my own students these days. Uh, uh, because back then, so it really depends, right? A senior prof is usually uh, very busy with getting funding, getting talks, and getting a lot of money to the lab, and that's their job, and that completely is understandable. But they don't have time, that much time, to sit next to you and tell you what works, what doesn't work. They have probably not coded for 10 years or 15 years. And again, this is not a negative thing, it is just how it is. So I didn't have the opportunity to have someone sit next to me and tell me, hey Raj, you know what, this will work, this will not work. During my PhD, I must have had close to like one meeting with my professor every 3 to 4 months. That's nothing. With my students, I meet them once a week or once every 2 weeks, and I can tell them, okay, show me your code, okay, this part is wrong, fix this, fix this, fix this, because I'm very hands on. uh, so if your professor is actually hands on and is actually able to spend time with you, please reward that effort of the professor by being proactive and actually appreciating the professor. You have no idea how good you have it sometimes, so please be appreciative.
Okay, so I
This
think
was mainly for the students, by the way, this was for the students.
let me have some students if they want to ask some question. I kind of covered the general questions that we
Hmm.
had as a group, research group. So kindly raise your hand, anyone who would like to ask a question, and then you can take. Okay, so Devdeep, you can speak. Let me unmute. Can you unmute yourself, Devdeep?
Yes, am I audible?
Yeah.
Yeah, I can hear you.
Yeah, good afternoon, Raj sir. It was an
Hi.
absolute pleasure listening to you. So, this question is not necessarily very aligned with machine translation or Indic languages, but more of a neural network perspective. So, as we know, uh, statistically, all kinds of data has a certain distribution, and all machine learning models do is sort of have an approximation to that data, and it is statistically infeasible to gain an absolute approximation of the data, since that would require infinite data. Now, similarly, LLMs are also only approximating language, but language, uh, by that sense, has some true approximation, some true data distribution, which can only be hypothetically attained. So, um, do you have sort of an intuition into what this true language data distribution might look like, and sort of like in very scientific terms, the KL divergence between what LLMs are and what they could hypothetically be,
Hmm,
had they
hmm.
had a very perfect sense?
Okay. I'll ask you one, let's say, related question, and then if you can answer that, you'll be able to answer that question yourself.
Mhm.
So, do you think you know your language perfectly well?
Not really, no.
Okay,
No.
so if we don't know, I don't, English is my native language. I grew up speaking English. I've been speaking English since I was in kindergarten because I went to an English only school. I've spent the past, every single content that I produce, written, spoken, is 99% in English. I still don't think I'm a master of English. If we cannot, as humans, do that, then how are we to hypothesize what the true distribution of languages is and how much this true distribution would entail? We could feed it a grammar book, but is there any are we sure that 100 grammar books will all comprehensively cover the entire language? And how do we ensure that it is also capturing the way languages are changing? Because I can tell you, as a 36-year-old, English has changed a lot, man. English has
Mhm.
changed a lot. The kind of English we used to speak back when I was in school is very different from what people speak now. And most people, formal English is of course there, but a vast majority of our life we are dominated with informal English, slang is like a lot of the stuff. Look at the internet, most of it is slang. So are we sure that we can capture slang, which is rapidly evolving, the language that is rapidly evolving? The true distribution is not static, the true distribution is rapidly moving. It is a moving, let's say, estimate. So unless we have a way to capture this moving estimate or evolution, it would be very hard for us to approximate what the true distribution of a language is.
Right, right. Thank you.
You're muted, Professor Murari.
Sorry, sir. Okay, so please raise your hand, anyone who would like to ask a question, and unmute yourself and go ahead and ask the question.
Yeah, I don't bite, so please feel free. You can ask anything. This is not necessarily related to just research or anything. It could be something that, at a personal, professional level, you're concerned about something. You can feel free to ask. It could be something philosophical. I don't mind.
Okay, Akash, you can unmute and ask the question.
Good afternoon, sir. It was a pleasure to listen to your talk. I actually wanted to ask something that I am struggling with. So I wanted to know if you have faced similar issues.
Please.
Sir, how do you build intuition for good research problems? How do I know whether something that I'm thinking of is worth pursuing? And if it is worth pursuing, like how do you build the intuition? of going around fixing the problem step by step and coming to a
Mm.
solution that is feasible. Because sometimes I find myself that, yes, I will have a good problem and I will find a solution for it, but I tunnel visioned so much because, well, it was a good idea, so I was like, okay, I have to fix it, that I did not think of other holes in my solution,
Hmm.
which comes up during peer review and really bites me back.
Right.
So I wanted to know about what your intuition and thought process is during this kind of
Right.
interaction.
Yeah. So if you would have asked me this question 10 years ago when I was just 4 years into my research career, I would have said, I have no idea. The only reason why I can have a better intuition, not a good intuition, better than 10 years ago, is because of the amount of time I've spent this. I have failed more than most of the people in this call. I can say that right now. uh, Failure is what is going to give you a solid intuition. Winning will give you only what works, but knowing what doesn't work is the only way to know how to separate a dumb idea from an idea that is very useful. So failure only comes from trial, and that means you have to get used to rapidly trying a bunch of ideas. Failing fast is very good. So I don't know if you've ever heard of Google's motto, but Google's motto is fail fast. If you fail fast, you learn faster. Failure teaches you more than anything else. Success only tells you what you're where you're right. Failure tells you about many more things. It also tests your character. So to develop that intuition, you have to be willing to try this. And we are human beings, right? We don't like to fail. Whenever something wrong happens, we are like, oh no, something I failed. It's We don't feel good about ourselves. You need to make yourself robust to that failure, and then just go and attack as many problems and any angles as possible. And always know that there is something called as a known known, known unknown, and unknown unknown. Unknown unknowns is something that you can never guard yourself against because you don't know what you don't know. But at least by reading a lot and trying a lot, you can know what you don't know. Right, you can figure out the gaps in your knowledge. You can use the gaps in your knowledge to supplement, oh okay, is this thing going to work or not? And that only comes through trial and error and a lot of time and a lot of experience. But you can never guard yourself about things you don't know, that you don't know. And that's actually a problem that everybody faces. And I don't know if there is a safeguard to that or not, but at least you can fill in your gaps, and that comes by extensive reading, trial and error, making mistakes, failing a lot.
Thank you, sir.
Okay, so I think let me ask one question, because
Yeah.
many of my students do get into this thing, like, because let's say we did some work, we submitted the paper, right? So they get too overly attached to the decision. So it because I keep telling them, see, really random, which you said, right? So just work on the next project, just forget about that. Whenever the decision comes, we'll do the rebuttal, whatever. We can even resubmit to next one, but it's really not a good idea to get attached once
Yeah.
you submit the paper, right? It can be really good paper, but still it can be rejected.
Right. Right.
So what would you say to
Okay,
us?
I have many things to say about that, but the very simple thing is, don't see, we are not doing research. We are not doing research because our because somebody's putting a gun to our head and making us do research. We are doing research because it's fun for us. Okay, don't turn research into some cat and mouse game where you're trying to aim for glory or you're trying to aim for success. At least that's my philosophy. Don't get attached to anything. Attachment is the worst thing that you can have, because when you have attachment, you will have the highest highs and the lowest lows. Okay, you have to understand that what you're doing as research is for fun. You are supposed to enjoy it. And just because your idea is not appreciated by other people doesn't mean your idea is bad. Okay, because people like Albert Einstein, he was laughed at when he came up with his ideas of theory of relativity. But you know how great of a man he is. I mean, even now, 70 years after his death, we are still celebrating. There are still things about his equations that people don't understand. So just because peer review has rejected your papers, and it has rejected the papers of very great people, did you know that the paper on knowledge distillation by Jeff Hinton, this was a paper that came out in 2014 or 15. It has never been published in any major venue. It has only been published in a workshop in Neurips. And the reason is because when they submitted it to the main conference, the reviewer is like, it's distillation, right? So what? It's obvious. But they missed the main point, that this was the first time somebody had shown it for neural networks at a different scale compared to what was shown 10 years ago or 5 years ago. And this is Jeffrey Hinton's work. If Jeffrey Hinton's work was rejected by ICLR NeurIPS level conferences, then if our papers get rejected, it's not a big deal. totally fine. So idea is, as Professor Murari said, please don't get attached to it. You do your work, submit it, next idea. Okay, you have to move on to the next idea, do the rebuttal, next idea. If you have done two rebuttals, three rebuttals, doesn't work out, put it in a workshop. Okay, if your professor is on your side, and if he needs you to graduate with publications, he'll be fine with anything. If your professor has a good feeling about you, they'll let you graduate. Don't worry about that. Everybody thinks, I need to get 4 ACL papers to graduate. That's not the case. In a number of times, the professor is very understanding, so take it easy. Okay, don't get attached. Attachment is the worst thing you can have.
Yeah, because particularly they are undergrad students, so they really
Yeah,
don't have any kind of obligation to actually take the degree with a paper. They can even
right,
get the paper after they
right,
graduate, and still it will be good, it'll be good for them, right? So I
right,
think the undergrad students, they have much more freedom, or like much more, I think, flexibility, right? Because they don't have an expectation for a paper from anyone, right? It's
right,
just adding to their profile, and it's just adding
right.
to their like future career and all.
Right. See, work on a paper that you really enjoy rather than just putting it on your resume. Inflating your resume with papers which you cannot explain
Yeah.
is the worst thing that you can do. And I can tell you, because I have interviewed close to a few dozen people for AI for Bharat interns and research assistants and AI residents. And I can tell you 90% of the people had an inflated resume but couldn't explain basic things. They couldn't even write the code for palindrome, first of all, which is very shocking to me. So, put on your resume the thing that you're very proud of and the thing that you've really invested your time into. Don't try to decorate your resume. And it's very easy for an expert to figure out what resume is inflated and what resume is a genuine one. So do what really shows your value. Your resume should be consistent, like, oh, okay, this person is really investing into this one specific thing, I like it. That is what I'd choose, a person who has one paper but he knows how to explain, he or she knows how to explain that paper really well. If you're working on 2 to 3 papers and no, I have to put it in ACL, I have to put it on NeurIPS, no, 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 you don't need to do that.
Okay. Manodeep, you can unmute and ask your questions.
Hello, good afternoon, sir.
Right.
Sir, I had a simple question. Let's say we train a model of different languages. Does that have any effect on the reasoning of the LLM? It's a simple question.
Right. So see, whether the language that you use has an impact on the reasoning of the LLM is a very good question. I don't think anybody's solved it. As far as I understand, I know for a fact that uh, when you train a model for English and you train a model for Hindi on roughly the same information, it is possible that the outcomes or the classification accuracies or the quality will be different, just because something is happening at an internal level which we don't understand fully. So it is possible that language will also impact the reasoning quality. So yes, of course, it is very likely that it will be the case.
Thank you, sir.
Yeah, you're very free to explore it. Okay, just take, let's say, Quen v3 model with reasoning, try to ask the model to reason in Japanese, try to ask it to reason in English, whatever, see if the outcome changes. It may really have an impact.
Okay, I will look into it.
Okay.
Arka, you can ask your question.
Yeah, thank you. A really interesting talk. I especially enjoyed the part in which you discuss the evaluation metrics that you have designed for your work. Something regarding that. So, if I were to do something based on NLP, then do you recommend a bottom-up approach in which I first run a lot of experiments and then try to formalize based on that? Or do you think having a hypothesis before beginning is a better way to do it? Because if we're looking at linguistics, the original field, it always looks at language and how it is used in society and formalizes based on that. So what would be your recommendation?
I'm afraid I will not have a clear answer on that, because everyone has their own way of doing things. I have done both. Sometimes it was a hypothesis that derived a bunch of ideas. Sometimes it was a bunch of ideas that derived a hypothesis. So when you have a bunch of, let's say, empirical findings, this is called as an empirical paper. But when you have a solid theory, like, okay, I want to focus only on this, that is essentially a hypothesis-driven approach. You should figure out what you're very good at. I would say, as a young researcher, you should try both ends. But if you the more senior you get, so the beautiful thing about a hypothesis driven idea, or a hypothesis driven experimentation, is that you have a strong motivation. Your explanation is clear, it's mathematically bounded, it's concrete. So you will know what will work and what will not work, but the odds that your hypothesis is wrong are fairly high. When it comes to empirical driven work, you will have a bunch of points, but not necessarily all those points fit on a single curve, so it is possible that you might not have a consistent hypothesis. However, the more experience you get, you'll be able to snip both ends of the spectrum, and you'll be able to come up with a hypothesis that you're fairly sure is correct, and therefore come up with a nice set of results. But you should not choose one or the other. I think it depends on every problem. Some problems are very hypothesis driven, some problem are very empirical driven. You should try both are fine in my opinion. But the scientist in me always says hypothesis is the best.
Yeah, that makes a lot of sense. Thank you.
But like early researchers, it's very difficult for them to come up with correct hypothesis, I
Correct,
guess,
yes,
because
exactly.
they do make a lot of, I think, random hypothesis, right, which doesn't make
Right,
any sense. But
right,
that with this experience, you get better with formulating better hypothesis, right?
right. So this is what so of course I have my own students coming up to me and saying like, hey, why don't we do this? It's like very randomly out of thin air they'll pull something, and I'm like, have you given it a thought? Have you tried it? Do you have any proof? They'll be like, no, it just came to me. And it's okay, Kekule figured out the benzene ring structure in a dream, but Kekule was a very renowned scientist, so for him to come up with that idea in his dream means he had a lot of intuition behind it. But that doesn't mean we are all Kekule, right? So when you have an idea, right, try to always pair it with some proof of concept, and not just come up with the idea. Don't walk into the meeting room saying like, sir, I have an idea, or ma'am, I have an idea. It shouldn't be like that. It should be like, I tried something, and based on that I have an idea, but I'm not 100% sure whether it will work or not. Therefore now it's the professor's judgment whether this should be pursued or not. But no random ideas, please. Just then it's a headache for me also. Like, okay, do you have proof of concept? Do you know whether it surely works or not? Do you have a positive example? And yeah, don't come up with random hypotheses, please.
Yeah, because I had experience where the students are not willing to even read the existing papers on
Oh
related to
yes,
that idea. They
yes,
just feel just because it came to them, it must be right, and they should write a
yeah,
paper on it. I said, you read, there must be someone has already done it, most
yeah.
likely.
Well, so I have a student right
Mhm.
now, extremely gifted, right, gifted person, but very young, just
Yeah,
21 years old.
yeah,
And they don't know what, 20 years old, 21 years old, and they just don't know the literature, enough literature to know whether so sometimes they'll come up to me and say like, hey, I had this idea. I'm like, this has been done 2 years ago, this has been done 3 years ago.
yeah,
The good thing is, at the very least, they have an intuition for what may work.
yeah.
That is a good thing, that is a great thing, it's a blessing, in fact. I like the fact that they are on the right track. It's just that you first, when you have an idea, please Google the paper once, whether you some idea is similar or not, and use Chat GPT or Gemini's deep search approach,
Mm.
feature. It's very useful. They can search the entire web and see if your ideas are similar or not.
Yeah, yeah. Great advice. Okay, Devdeep, you can ask your question.
Yeah, just one last question, nothing to do with research, but you've been into research for so long, and I've been following your tweets. You have amazing philosophy about life and research as well. So, research, it's because it's so disciplinary, it teaches you a lot. So, if you had to sum up all that you have learned doing research about life,
Mhm.
how would you put that in like very short phrase?
Sum up everything that I've done research about life, or
No,
can you be a bit?
like, yeah, like doing research, what have you learned about approaching life or somewhat living through it? Because you've been through
Hmm.
it, so it's a hard work. There's a lot of
Mm-hmm.
turmoil. So what have you learned through all of this?
What doesn't kill you makes you stronger.
I see. That's an amazing thing. Thank you so much.
Actually, I think I'll ask a follow-up, slightly different but follow-up. So I think students sometimes misunderstand that good researcher means lots of money. So so if some
That is wrong. I've been poor for the past 7 years. That is a very wrong understanding. I don't know why people think
so
that.
if someone wants to be a researcher and also wants to earn money, is there any way for that?
Yeah, go to industry, Google,
Go
Microsoft.
to
They will, okay. The researcher title is industrial research, so they will have very goal oriented things. You'll
yeah.
not have as much freedom, unless you're the super duper researcher, in which case they'll give you whatever freedom. And if you're Ilya Sutskever, they'll probably give you a special cabin and be like, okay, sit there and do your own thing, but don't disturb anyone else. Uh,
Mhm.
so So if you want to make money, don't do research. There are many ways to make money. Go invest your money. Go do investment banking. If you want to make money with research, it's kind of ironic, because research is more about your passion. Money is something that you can make out of research. Okay, I have something to share with you. This is probably something I share only on specific occasions. When I was 23, I was going from my hostel to the main gate in IIT Bombay, and we were all talking about job hunting, because everyone is like, okay, now it's job hunting season, so we know that Google will come, we'll know that some American companies will come, and I was like, okay, I'll take an offer from an American company and I'll go and make a lot of money. So this one very unique guy who was sitting in the bus, very, like, he looks like a mad scientist, and he really is a mad scientist, but he's one of the greatest people that I've ever met in my life. Outstanding person. He comes up to me, he's like, Raj, I like, and we knew each other because we used to attend the same classes sometimes. And I'm a very loud person, so he kind of used to overhear the way I used to talk. And he's like, Raj, you're the last person who should be running after money. You can make money anytime. You should spend more time focusing on something that you are driven by, something that drives you, something that you're passionate about. Money will come to you the day you want it. And he was not wrong. In I when I finished my master's degree, I had an offer to go to America to be in a kind of healthcare based software company, where they were giving me back then almost 120,000 US dollars worth of salary, which is pretty good. Huh? This is a very good salary. If I wanted to, I could have chosen it, but I didn't. I chose to do my PhD. I was poor. At the end of my PhD, I had the chance to work in Clova AI, which is, it's naval, one of Korea's big research labs, and they publish in NeurIPS, ICML, ICR, Solid. I would have made a lot of money, but I was like, no, I'm not ready. I'm not that deep into research. I need to know more about what the world of research is like. So I gave that up. I chose to stay in NICT, which, by the way, is an outstanding place. It's just that it doesn't pay as well because it's not industry. I had probably done job hunting a couple of times while I was in NICT, and both times I had already gotten very good offers to get money. The point is, when you are passionate about research, about becoming a good researcher, and you have mastered that skill and you have pushed that skill to the limit, the moment you want money, you can always make money. A good researcher will be able to make money no matter what. It is a question of time. So don't run after money. And see, it's the three idiots thing, right? Go after excellence. Okay, excellence is what you should be aiming for. Success will come to you. Money will come. Money is actually surprisingly not that hard to get by. Money anybody can make. It is about being the best researcher, about the most excellent person, the peak of your capabilities. That, I think, is harder, and you should aim for that.
Yeah, I think this is the case. I think as a researcher, we should be ready for delayed gratification over instant gratification.
Yes, absolutely. And delete Snapchat and Instagram and all of that stuff, because that is the thing that exacerbates your need for instant gratification. Social media is not a good thing. And I should be saying that because I use Twitter a lot and it's not a good thing.
But I think some is good because that's how we connected.
Sure. Yes, of course, of course.
Because to connect with some research, I think might be good to at least occasionally be on Twitter, because I think most of the researchers, good researchers, are trying to be active, at least trying to be active. This is
Yes,
how we can connect, and the students can get their insights. This way it's good, but I think
yes.
other platforms are not that useful.
I agree. So cutting down is good, is what I want
Yeah,
to say.
yeah, yeah. Okay, so anybody else has any questions? Feel free to ask. Okay, Ankit, yeah, go ahead and unmute yourself.
Hello, sir.
Hi.
So, like, you have seen that Jan LeCun, occasionally advertises about the LLM's limitations and talks about working on new architecture. So, have you ever thought of working on any other architecture, or thought like this could be better than LLMs, something?
Okay, I have very good reason to believe that the LLM research is not going to be the thing that leads to AGI. It will lead to super intelligence, but I don't think it will lead to general intelligence. General intelligence will need some form of synthetic human machine hybrids, which is still way ahead into the future. We want general super intelligence, which is way ahead into the future. I think there should be something better. Current LLMs, they have their own limitations. They are just an approximation of the actual neural network structure, which is present in our brain. If we don't understand that, we are not going to come up with anything else. So you need to invest in neuroscience also if you have the capacity and the capability for it. LLMs, I think the hype will die down personally based on what I've seen. I know that statistical machine translation came out in like late 90s, and it became really crazy around 2005, and then it just went down and kind of became very vague. Then people came up with hybrid approaches. Then encoder decoder approaches came in, and 2017 was this crazy hype, and then it kind of died down, and somebody came up with scaling. Now scaling is becoming the hype thing. It is going up, and now the limits. So it is about pushing things to the limit. When scaling has been pushed to the limit and they realize the amount of juice you can squeeze from it is getting low, that is where innovation will come in. Stagnation is very good for the next phase. So just wait something. And come on, physics has been evolving for the past 200, 300, 400 years. Computer science is just new. It's very fresh. Give it time. There will be something new, I'm sure. That being said, Jan LeCun is already thinking 10 years into the future. And Jan LeCun, even if he's a Turing Award winner, doesn't mean he knows everything. That being said, someone who is just is started out on their PhD journey doesn't mean that they know nothing. It's all about it's something like this, right? It is very easy to look back and say that was the right decision, but it is very hard to know. Prospect is a very dangerous rationalization. Retrospect, nobody knows how to have the retrospection into the future. So you don't know. All you can do is keep your mind open to the possibility that there could be something else, and if you have the time, invest in that something else.
Okay, sir. Thank you.
Yeah, actually, that was also my thing. Like, it's not that current people, researcher, like either PhD, undergrad, postgrad, whatever. So they should not. It's not that they should not work on LLMs just because it may or may not lead to AGI, or like it may not be the uh, modality which may last for long. But currently, LLMs have so much to offer us, right? So we should
Yes,
explore that, right?
yes,
Whenever
yes, yes.
it's a wall, we would naturally transition to the next big, next ideas that will lead us to next step, right? So that has always been the case previously also.
Right,
So that doesn't, like, even if let's say Ann LeCun has that made that prediction that LLMs will not lead us to AGI and all, that doesn't mean we should stop working on LLMs because
right.
it's so
No,
nice.
definitely not. Definitely not. So uh, only when we have squeezed every last
Yeah,
bit of juice from the LLM world is when we will come up with the next, and it will come up very naturally.
yeah.
Every single time humans hit a roadblock, the next thing always comes up. So just make sure you're contributing not towards redundant things, but always towards a new angle, which is going to be like, okay, we have attacked LLMs from this perspective. Now I know this, and when we come to a situation where ideas are running out, that's when the new thing will evolve.
Yeah, because I feel like some, not many, but some students or some researchers start uh, becoming kind of, I don't know, kind of lazy, using these quotes as a justification why they're not working on LLMs. I
Right,
feel that doesn't make sense. Like, even if it's true, right now
right,
we are getting so much out of it, right? So why should you not contribute to that effort, right? As a
right,
researcher, like,
right.
right now, can you have? Do you have anything better? No. So
Right. Alternatively, propose something better,
yeah,
right?
yeah,
If you are reading deep into Jan LeCun and Jeff Hinton, etc.,
yeah,
uh, show something, right? Come
yeah,
up with, like, for example, Jeff Hinton had proposed this capsule networks like about seven,
yeah,
8, 9 years ago,
yeah.
which blew up for some time, but then nobody figured out. About a year and a half year ago, somebody came up with, God, what is that thing? It was called as
Kolmogorov
Yes,
networks.
Kolmogorov
Yes, yes,
Arnold networks, right?
yeah,
And actually, I was excited by it. I was like, okay, finally, we have something new.
yeah.
And I thought I'd implement this. Then 1 week later, somebody says, like, oh, actually, there are some flaws in the paper. And I was like, oh, I see. Okay, that's really sad. Um, I would say that put your mouth where your money is.
Yes, yes,
Okay. Don't read into, and by the way, don't read into hype. For God's sake, there is way too much hype going on in social
yes.
media. There is way too much FOMO going on. Do not give into this. So be very grounded. Being grounded is very important. It's underrated.
Actually, particularly, I was actually talking to one of my friend, and I was saying like how these big tech companies, CEOs, and all, they're actually fueling this hype
Yes,
because they know that this will kind of increase the revenue of the company, high valuation, all those things, and they're saying the things what people want to hear, not like
right, right,
what is the actual ground reality regarding AI. But
right.
even I'll add Sam Altman, all these people in that list. Like, even Sundar
Oh, I
Pichai
mean,
also.
these
Yeah,
are all businessmen. They
yeah,
want to make money. They like, for example, I can tell you this. I have a friend
yeah.
who is a independent contractor and consultation expert for a number of companies,
Mhm,
and he, of course, he I can't give his name, and he
mhm,
cannot give me his clients' names.
mhm,
But he says like most of this is they're trying to sell something, because
mhm,
what happens is that these venture capitalists, right? They have millions and millions of dollars, and they
mhm.
need to dump it somewhere, so
Yeah.
they need someone who can talk big without any proof. You can walk into a room, tell them, I want to build, let's say, a biosynthetic human being with LLM backup,
Mm.
and they will throw money at this because it sounds cool, and that is how they justify it to their own investors.
Yeah.
And if you don't hype, you are not going to make money, and that's the bad side of industry. But you need money to do these things, and most of the advancements come from money. So when you see like someone saying, oh, Gemini has done this and done that, it's a very very carved out narrow view. In a very general perspective, LLMs have not made any major progress since the time they were introduced. If you see a basic machine translation system architecture from 8 years ago, is still better than any of the biggest LLMs which are publicly available. So don't jump into hype. It's the bad way.
Yeah.
Okay,
So,
so
yeah.
I think now I have to go. I have
Yeah.
family duties
Also,
to
I
handle.
think we have pretty much exhausted all our questions. I hope.
Okay.
Does anyone have any questions?
Yeah, you can just send me an email, right? I've put in my Gmail. So just send me an email. You have any questions? Please ask. Please, if you do ask me a question, don't be don't write like 10 paragraphs worth of exposition. Ask the pertinent question so I can give you the correct answer.
Yeah. Don't use ChatGPT to
Oh
answer.
yeah, and you don't need to be like, oh, like in my journey I have become this. No, please don't write that. Be direct, be respectful, be direct. That's all.
Yeah. Yeah. Okay,
Okay,
sure.
cool.
Thank you. I think we had a wonderful session, and I think all the students learned so much from you. I am really hoping it will be really useful, really helpful for their research journey and for their like, life's journey as a researcher to advance in that field of NLP, LLM, or AI, whatever. So, yep. Thank you for accepting to come or this talk. We had a really nice time.
Yeah,
Yep.
thank you so much, Professor Murari. It was my pleasure. When you sent me that message saying that there are many students who look up to me, it was very touching to hear that. But that being said, I would like the people listening to me to aim higher than me and to surpass me. Okay, everyone has the potential. Just do your best. It's possible. It's definitely possible.
I think these talks inspire them also. That's my kind of understanding. So that's why I like them to get interacted with people who are doing great research and also. I think this
Sounds
is
good.
definitely motivational for them.
Yes, definitely.
Thank you. Thank you.
Okay, thank you so much, Professor Murari. I'll take my leave
Thank
then.
you.
Thank you.
Bye bye.
Thanks everybody for having me. Bye bye.